All right, lesson 3 expands our last lesson of quadrilaterals being special quadrilaterals being parallelograms. We're going to today talk about 3 other types of parallelograms. And those are special parallelograms. And you can see our objectives. And here are those parallelograms: a rhombus, rectangle, and square. Now, each of these are all parallelograms, and all 5 things are true. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. But they also share their own unique qualities apart from parallelograms. So a rhombus is a special parallelogram because it has 4 congruent sides. A rectangle is a special parallelogram because it has 4 congruent angles. Obviously, they're all right angles. And a square is a parallelogram that has both. So it's a rhombus and a rectangle. And we better known as equilateral and equiangular. So a rhombus, since all the sides are the same, is called an equilateral quadrilateral. A rectangle is called an equiangular quadrilateral, and a square is both, so it's called regular. It's a regular quadrilateral. Okay? Now, what's special about these? Here's the descriptions, okay? But what's special about them is they share characteristics of parallelograms, but they also might share some things with each other. And specifically, if you have a square, you also have a rhombus and a rectangle. It's both. So some rectangles are rhombuses when they're squares, and some rhombuses are rectangles when they're squares. But all squares are rhombuses and rectangles, and all 3 of them are parallelograms because opposite sides are parallel. Now, knowing this, let's talk about whether a rhombus QRST, if this is always or sometimes true. So you have to draw a diagram. So let's draw a little kicked over square, all sides equal, and we're supposed to label it QRST. Is angle Q congruent to angle S? Well, opposite angles are congruent, so that's an always characteristic of a rhombus. How about angle Q congruent to angle R? That's not true, is it? Not always, but it is sometimes. If you think about it, it would be true when it's a 90-degree angle, and that's true when it's a square. But remember, a square is a rhombus. Okay? What about this? JKLM, square JKLM. Okay? So those are all 90, JKLM. Is it always or sometimes true that JK is perpendicular to KL? Well, if it's a square, it's always, isn't it? How about rectangle EFGH? Okay, EFGH. They're all 90. Is it true that FG equals GH? Well, it would be sometimes if this rectangle were a square. So it'd be true if it's a square. So it's sometimes true because not all rectangles are squares, right? But some rectangles are squares. Okay, so how would we classify this quadrilateral? And then explain it. Well, it has 4 congruent sides, right? So it's got to be a rhombus. It cannot be a square because it's not 90 degrees. Okay, that's easy. A quadrilateral has 4 congruent sides and 4 congruent angles. Sketch the quadrilateral and classify it. Well, that can only be a square, right? So that's our classification. It's a square. Now, there are special things about each of these 3 special parallelograms. Let's start with the rhombus. Now remember, all those things are true about a rhombus. So 1 through 5, all 5 things in a parallelogram are true. Okay, all those properties. But, and also all sides are equal, right? All sides are congruent. But here's the other two, 7 and 8. The diagonals are perpendicular. So they make a 90-degree angle. That's only true in a rhombus. And the diagonals also bisect the angles of a rhombus. So they cut the angles in half. So angle A here is cut in half, angle C is cut in half, angle D and B are cut in half. So opposite angles are still congruent, but they're also bisected in a rhombus. Okay? And so because of this, then we can look at some examples here. We'll use black again. So remember, diagonals are perpendicular, so that makes angle 1 90. We also know that the diagonals bisect the angles. So if this is 61, so's this. So that makes 2 and 3 61. That also makes angle 4 what? Got to add up to 90, doesn't it? 29, 61 and 29, because we have a right triangle right here, so we have to have 180 degrees, so that's 29. So's this, so's this, so's this. Okay? So then it wants to know what's the measure of angle ADC. Well, that's 29 times 2. And BCD is 61 times 2. And those have to add up to 180 because they're consecutive angles. And they do. Let's see. Angle G is 118. That makes E 118. Now we're supposed to find 1, 2, 3, and 4. But remember, these are equal. And so are these. It's a rhombus. So that makes it an isosceles triangle. So 180 minus 118 is 62. So these all have to be 31. We could also do, if anybody was thinking the whole thing, 118 plus 62 is 180, and then divide by 2. You could also do it that way as well. Okay, that's how we apply the rhombus properties. Now, a rectangle still is 1 through 5, the parallelogram. But it has, I'm going to go number, what is that, 7, 8, 6, 7, 8. So this would be the 9th property that we're going to talk about. Diagonals are congruent. And this only exists in a rectangle and a square, because remember, a square is a rectangle. So the diagonals are congruent. Not only are they bisected, they're also equal. They're congruent. So this is what we call the Carpenter's theorem. And that comes from the fact that carpenters use this all the time when they're keeping things square. They're keeping 90-degree angles. They just measure the diagonals. Because most buildings they build are going to be rectangular, 90 degrees. So knowing that, then, we have to make sure they're 90, and we do that just by measuring the diagonals. And if they're equal, we know we have a 90-degree angle. So here's a little picture, 33 and 44-inch frame for a window. And the opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? And most of you would say yes. But I'm going to say no. Because it could be a parallelogram. Because you could still have a parallelogram here. Do we know those are 90-degree angles? Not necessarily. We can prove them, though, prove that they are, if that diagonal equals that diagonal. But it says these diagonals are not. They're different. So what can you conclude about the shape of the opening? It's not a rectangle. It's a parallelogram. And that directly comes from the fact that the diagonals are not congruent. Okay, so it's very practical. Here's a little algebraic use. QS obviously is 5x minus 31, and RT is 2x plus 11, and we know they have to be equal because they're diagonals of a rectangle. So we have to find their lengths. Well, we get the x's together. Okay, that leaves us with 11. Add 31. That's 42. So 42 divided by 3 is 14. So that doesn't give us the diagonals, though. That only gives us x. So we're going to put 14 into one of these. Doesn't have to be both. But 2 times 14 plus 11 would be 28 plus 11, and that equals 39. So those diagonals would be each 39. I don't know if it's inches, centimeters, feet, whatever, what have you. Okay, and then the last one, we have a parallelogram, we think, and we're supposed to classify it as a rectangle, a rhombus, or a square. And I think we can all tell that it's not a square because we don't have 90-degree angles. Same way with a rectangle. So it's either a rhombus or it's just a plain old parallelogram by looking at the picture. How could we be sure? How can we be sure we have a rhombus? Well, the first thing would be, let's look at the slope of this line right here. 1 over 4, right? So that slope 1/4. That slope is 4 over 1. This slope is 4 over 1. And this slope is 1 over 4. So the opposite slopes are equal. So we know they're parallel. So we know we have a parallelogram. Now, would those side lengths be equal? Well, I'm pretty sure that if you have a triangle that's 4 by 1 and 4 by 1 and 4 by 1 and 4 by 1, you would have, if I did the Pythagorean theorem on all 4 of these, this answer right here, these x's would all be the same, wouldn't they? Because it's the same Pythagorean theorem. So that would make this a rhombus, a special parallelogram called a rhombus. The reason it's not rectangular, remember, the reason these aren't 90 is because our slopes, let's see, this slope was 1/4 and 1/4, and this was 4 and 4. Remember, to have 90-degree angles, we would need perpendicular lines, and the slopes would have to be opposite reciprocals. Okay? Again, check for Canvas.